Classical logic usually refers to the standard systems of propositional logic and first-order relational predicate logic with identity. These systems form the foundation of most contemporary logical theory and are widely used in mathematics, philosophy, computer science, and linguistics. In propositional logic, the basic units are propositions or sentences that can be either true or false. Complex propositions are formed using logical connectives such as negation, conjunction, disjunction, material implication, and the biconditional. The meaning of these connectives is typically defined by truth tables. First-order predicate logic extends propositional logic by introducing predicates, singular constants, variables, quantifiers, and identity. With these tools, we can represent statements about objects and their properties, such as all humans are mortal, or there exists an object that is red. The quantifiers, that is the universal quantifier, for all, and the existential or particular quantifier, there exists or there is, allow us to make general and existential claims about individuals in a domain. Classical logic assumes several important principles. For example, every statement is either true or false, the principle of bivalence, and contradictions cannot be true, the law of non-contradiction. Another characteristic principle is the law of excluded middle, which states that every proposition is either true or its negation is true. Classical logic developed over a long period of time. The earliest systematic work in logic is usually attributed to Aristotle, who developed the theory of syllogisms, and the Stoics, who introduced a kind of propositional logic. Modern classical logic, however, largely emerged in the 19th and early 20th centuries. It overcame the ancient split between syllogistic and sentential logic. Perhaps the most important contributor to this kind of logic was Gottlob Frege, whose work laid the foundation for much of modern logic. Later developments were made by figures such as Bertrand Russell and Alfred North Whitehead, who mainly studied classical logic from a syntactic, axiomatic, and proof-theoretic perspective, and Alfred Tarski, who influenced the semantic study of classical logic. Other important contributions came from David Hilbert and Kurt Gödel, whose work on completeness and incompleteness theorems helped shape modern metalogic. The expression non-classical logic usually refers to logical systems that differ from classical logic in some important respect. Such systems may modify or reject classical principles, introduce new logical operators or theorems, or change the underlying semantics of the logic. Non-classical logic has become a large and diverse field. Many systems have been developed to capture forms of reasoning that classical logic does not seem to adequately represent, such as reasoning about time, possibility, obligation, uncertainty, or vagueness. Some non-classical logics are best understood as extensions of classical logic. These systems retain the principles of classical logic but add new operators or concepts. Examples include standard forms of modal logic, which introduces operators for necessity and possibility, temporal logic, which allows us to reason about time and temporal relations, epistemic and doxastic logic, which concern knowledge and belief, deontic logic, which studies obligation, permission, and prohibition. In these systems, the underlying propositional or predicate structure of classical logic usually remains intact, but additional expressive tools are introduced. Other non-classical systems are alternatives rather than extensions. These logics reject or modify some classical principles. Two important kinds can be distinguished. First, there are systems that are strictly weaker than classical logic, meaning that they validate fewer principles. For example, intuitionistic logic rejects the unrestricted use of the law of excluded middle. As a result, some classical theorems are not derivable in this system. Second, there are systems that are both weaker and stronger than classical logic. They reject some classical principles, but introduce new ones that classical logic does not contain. For example, connexive systems are often of this kind. Such systems are sometimes called contra-classical. Other examples of non-classical logics that are not straightforward extensions of classical logic include substructural logics, relevance logic, many-valued logics, fuzzy logic, and various forms of free predicate logic. The distinction between classical and non-classical logic plays an important role in contemporary logical theory. Classical logic provides a widely accepted and well-understood framework that serves as the foundation for many areas of mathematics and philosophy. That is why it is called classical. Many believe that first-order relational predicate logic with identity, which is an extension of classical propositional logic, is the true logical system. According to them, non-classical logic is in some sense misguided. However, not everyone agrees. Many believe that classical logic is correct, but that it should be extended in various ways, and some believe that classical logic should be modified in some other sense, for example, by making it weaker or both weaker and stronger. Non-classical logics explore alternative principles and forms of reasoning and often add new logical operators and rules of inference. Together, these systems illustrate the richness and diversity of modern logic and show that logical theory, at least seen from a purely formal perspective, is not a single fixed system, but rather a broad field of investigation into the structure of rational thought.